Now, having looked at maturity models, particularly software development maturity models, and talked about the capability levels and the dominant problems, let's now look at the dominant problems. So just to review, there is the 5-level capability maturity model that has been widely applied to software and now has actually been applied to a lot of places outside of software. But at level 1, work gets done. The implemented process achieves its process outcomes. Right? So whatever's going on, work comes out. At the managed level, the previously described perform process now is implemented in the managed fashion. So there's a certain amount of planning and there's a certain amount of control going on. So it's a little bit less chaotic. At the 3rd level, there is actually a defined process. So now we've got something written down, there is a defined process for doing things, and this is quite transferable across the organization. Importantly, at the defined level is defined probably across the organization, so we get common ways of doing things as best we can. Level 4 is quantitatively managed. So the previously described defined process, now we start putting a bit of science in it. Now we start taking the measurements and analyzing the data to see what actually is improvement or what actually is a problem. At level 5, we start looking at anticipating problems or anticipating changes in the environment that are going to require changes in our process. So it's an optimizing process, and that we'll revisit that later. So level 1, as you see, there's a beginning, a muddle, and an end. When the international standards community was developing the international version of the CMM, the question was, could you have a level lower than 1? Because at 1, the work got done. And the answer was yes, you can have a level lower than 1. So there is a level 0, if you want, where nothing reliably happens, as you can't depend on it. Whereas at level 1, at least you can depend on the work getting done at some stage in some way. But there is no established method to develop software. It's kind of muddled through. So that's the dominant problem. And you could say, well, it happens because somebody knows what they're doing, but not everybody. The work gets done through heroic effort. So the first thing you have to do is to try and establish, how do we actually do this? How do we actually develop software? At level 2, people actually know they know how to develop software, but it's not well estimated and it's not well planned, and you get it when you get it, and you know, it could have regressive bugs in it from time to time. So the work is neither planned nor controlled. You get project overruns, you get persistent defects. And the cure for this is you put in basic project management, basic project estimation, basic work breakdown structure, basic planning, and put that in place. That's the first thing you do. That's also resource management. You know, how many people do you need? What skills do you want? This is a basic project management. Similarly, you put in basic work product management. So there's configuration management, version control, defect control, change management, build management, release management. Those kind of things that keep the work under control, so that you're not slipping defects and mismatched files into the work product all the time. So they are the cures for level 2. Now level 3, different people use different processes. This is quite frequent in software development, because people do have their favorite process, they have their favorite language, and all sorts of reasons why what they're doing is the right one and why they can't use any other process. However, this doesn't work well when you're moving people between products, or when they have to work on several different products, or you have different parts of the organization having to exchange work. Probably a bigger deal when you're dealing with distributed processing, where you have less visibility into how they're doing something, and yet you still need to exchange work products in one way or the other. So the whole idea at level 3 and bear in mind that the CMM was developed in the early 1990s, prior to the large uptake in distributed development, and particularly global development. So there was a reasonable assumption that the distribution would be within an organization, in which case you were able to exchange best practice within the organization. So if obviously if one part of the organization figured out how to do something better, there was probably an obligation to propagate that through the organization so that everybody improved and everybody knew what was going on. So that's one of the ways you can improve that. That is through establishing a defined process, which these days is much easier with the internal webs, because you can simply put up the process on the internal web, and that's there for reference for everybody, and everybody gets trained the same way. And you do propagate improvements through the organization. Now at level 4, here is where you're actually starting to put a great deal more science into it. And this is where you start measuring a lot of things about the work. So you'd measure obviously defects, you'd measure, but also how many resources you're putting in, how much time it's taking, or anything else that you think is relevant to it all, so that you get some data that you can analyze to say what actually is causing the problem. And it won't be a problem, it won't be a cause. There'll be lots of causes and lots of problems, and you just gradually pick them all off. The whole idea with level 4 is you're trying to pick off the special cause variation. That is, things that happen once in a while and are not actually endemic to the process. So these would be things like somebody did something wrong because they didn't know how to do it right, or some product came in incorrectly, or it had a bug in it, or there was some slip up somewhere on the place. These special causes of variation are things that you need to get under control before you can do much else. But measures are a pretty good way of going about it. Once you have that under control, you then go on to the next level, level 5, where in this case you're looking at common cause variation. That is variation that is endemic to the process itself. That is actually so much a part of the process that you have to change the process itself. Now this could be you change the tools within the process, or you come up with a different type of practice, or work practice, or some other technique within the process. For example, if you're doing software development, you're doing the construction itself, you're doing the coding, okay? And you have a habit of doing peer reviews, and this has achieved a certain level of quality. Now you've decided that that level of quality is not going to be good enough for the next project that you want to bid for. So somehow you need to improve the quality of things. Well, you can do a couple of things. You could implement automated unit testing. You could put in a much more rigorous compiler. You could change the language to one that's less error prone. Or you could put in the personal software process, which is highly rigorous and extremely effective. Requires a fair bit of discipline, but if you're going after that level of defect freeness, then that's what you need to do. So that's the kind of thing that you need to do at level 5. And these things at level 5 are an endemic part, or they are part of the process, not something external to the process, and that's what you're fixing.